This is a great place to see. I appreciate you coming. This is the ICRI forum called You Call It Sustainability, We Call It Concrete Repair. My name is Fred Goodwin. I'll be the moderator this afternoon. The venue will be, our goal is to engage ICRI for an understanding of the concrete repair industry related to green and sustainable construction. Each panelist will give a 10-minute presentation. Following the presentation, we'll take questions, discussion from the audience. Please remind us to repeat the questions because we do not have floor microphones, or if you care to come up to the podium, that would be fine. At about 3:45, or when things are winding down, I'd like to capture any deliverables or go-forward steps from the forum. If you have a cell phone, be kind enough to mute it, put it on silent. That would be appreciated. If you need to hold side discussions, if you'd be kind enough to do them outside the doors, that would be appreciated as well. We did a survey electronically with ICRI. We had 238 responses. The survey was only open about a week. The first question of the survey is, in your opinion, what's the relationship between sustainability, green building, and concrete repair? Majority of people felt like it was the same thing. Next question, when involved in a concrete repair project, how often is sustainability, embodied energy, green building, recycling, environmental impact, energy usage, and so forth mentioned? The answer there was maybe occasionally, but it's not really a focus of anything. Will the effects of the current economy have an effect on concrete repair? Most people felt like it'll remain steady without much emphasis on sustainability. What should ICRI do to promote sustainability in concrete repair industry? Overwhelmingly, we felt like we should develop it as a strategic objective. Have you ever worked on a LEED or Green Globe certified project involving concrete repair? Doesn't seem to be very common. Maybe a little bit, but mostly never heard of it on a project. And should concrete repair techniques be rated for sustainability, embodied energy, green building? There the answer was pretty ambiguous of the respondents. So what do we mean by green building? These aren't official definitions. They're kind of what I've put together by surfing around on the internet. Green building is a practice of increasing the efficiency with which buildings use resources, that is energy, water, and materials, while reducing the building impacts on human health and the environment during its life cycle. Sustainability is a little bit different. It's the quality of a state or a process that allows it to be maintained indefinitely by integrating environmental, economic, and social systems into a system maintainable in a healthy state. The classic definition is the ability to meet the needs of today's people and environment without compromising that of subsequent generations. Sustainability aims to create an environment that can renew itself without damage to future stakeholders. My version is green building's a practice of continuous improvement of resource usage and reduction of negative consequences through a structure's lifetime. Sustainability takes it a step further and considers factors beyond resources to create self-renewing situations, with green building only one of the components. So kind of an example I thought of that might take all these big words and make them a little more user-friendly. In economics, sustainability is a net zero or positive cash flow. That is, you invest and you get rewards for your investment. And you can then in turn invest again. Evolution of building materials. We started out with the wood age. The first materials that human beings built with were wood, mud. We then started using stone as our main building material. That evolved into masonry, and finally into steel. We're now in the concrete age, folks. Our most significant structures, the world's tallest building, is 45,000 cubic meters of concrete. The world's largest dam, with the highest electrical generating capacity, is 2.6 million cubic meters of concrete, supplying 100 terawatts of electricity a year. Our longest bridges are also concrete. Depending on how you count it, if it's a bridge over water, it's the Pontchartrain Causeway. If it's the longest elevated structure that holds traffic, it's in Thailand. Both used huge amounts of concrete. Despite all of this, sometimes we don't do so well. American Society of Civil Engineers provides an infrastructure report giving us letter grades every several years. And they provide an estimate of how much money is required to bring us back up to a C grade. In 2005, we got a D for our overall infrastructure, and the estimate was $1.6 trillion invested over 5 years to bring our infrastructure back to acceptable standards. It's divided into a number of categories, and I dare say every one of these categories involves concrete in some way, shape, form, or fashion. The latest grade, we still have a D, but the money has gone up to $2.2 trillion. It's a lot larger than the bailout package. Furthermore, we produce about 1 ton of concrete per year per person in the world. That's increasing about 1% a year. The world trade, the economic impact of concrete and related industries is between $13 and $14 trillion per year. And it takes about 1% of our jobs are related to concrete. It also accounts for about 1.6 billion tons of carbon dioxide per year, about 8% of the CO2 emissions when you figure in aggregate, production of reinforcing steel, transportation of materials. It accounts for 67% of the weight of construction and demolition waste, with only 5% currently being recycled. Consumes 60%, construction consumes 60% of the U.S. raw materials, not accounting food and fuel, produces 160 million tons per year. 1/3 of the U.S. non-hazardous waste is from construction activities. Demolition accounts for 48% of that. The amount of built space in the United States was 300 billion square feet in 2000. It's expected to grow to 430 billion square feet in the next 30 years. And we will replace about 25% of our current buildings between 2000 and 2030. We are a disposable society when it comes to structures. Yet when we try to repair them, they don't do so well. The U.S. Army Corps of Engineers said only 50% of their repairs performed satisfactorily and weren't too happy about it. Another study conducted over in Great Britain also found only about 50% of the repairs were successful, and the deterioration rate with time was quite rapid. A repair that was satisfactory in 5 years, only half of those that were good at 5 years were still good at 10 years, and so forth. And how much does it cost us? Vision 2020 estimated $18 to $21 billion a year in the U.S. alone. However, there's some hope. Remember the days of design bid where the engineer would put up a bunch of plans, call up his contractor friends and say how much it's going to cost to build this? We've now moved a lot towards design build, where the engineer and the contractors, the applicators, work together. Many new significant projects are design, build, maintain. The same people building it and designing it are responsible for its operation. Eventually, if we're I think we'll move towards design, build, maintain, decommission, a cradle-to-grave strategy. That is, if you're going to build something, figure out how to take it apart when you're done. Think of a nuclear reactor. If I built it with the intent of taking it apart, life would be much easier and safer. But where we would really like to be is design, build, maintain, and rehabilitate. That's a cradle-to-cradle strategy where the components of a structure are reused to create new uses. Adaptive reuse of structures, that's sustainability. So I'd like to introduce our panelists. You know me, I'm Fred Goodwin. I work for BASF. Our next speaker will be Paul Turney, President of the Turney Consulting Group. He's the chair of the ICRI Life Cycle Committee. He'll be speaking on evaluation of structures, life cycle, and service life, followed by Andrew Viter of Walker Restoration. He's the ICRI Michigan chapter president for 0809. We'll be speaking on specifications, tax credits, owner benefits, waste management, followed by Dr. Tanya Comas, Concrete Industry Management Coordinator of the CIM program from California State University, Chico, on educational resources, ongoing research, and preservation. Sherry Brzezinka, who is the Executive Director of the Minnesota Headwaters Chapter of the United States Green Building Council, responsible for the LEED program. She'll be speaking on USGBC and concrete repair. And finally, David Whitmore, President of the Vector Group. He'll be speaking on environmental planning, materials, and application methods. So with that, I give you Paul Turney.
Thank you, Fred. Wow. Evaluation of structures, life cycle, and service life in 10 minutes or less. Well, let's see if we can do it. Just a couple points. I looked at Fred's presentation. I looked at this, and there's a couple striking things that people need to realize, and I'm sure most people do here, is that highway bridges, we build about 1,000 of them new each year, and we have a backlog of 600,000 of them out there, and right now they're saying the grade's about a C. There's a tremendous number of road miles, and there's probably that are built every year, and there's easily 100 times more than that already there, and they have a grade of D-. Parking garages, about 400 built per year, have a total of 25,000 of them out there in the United States, and they have a grade of about a C. Dams, not very many are built, and we have a very bad grade on a very important infrastructure item in our country right now. This is very striking. I mean, you can do some impact on sustainability on new construction, but this group here, with this kind of a grade, seems pretty striking. It comes with a couple recommendations is let's build our new structures to last longer so we don't have to deal with them while we're dealing with the backlog of structures that are out there that need better repairs to keep the cycle of repairs further apart, because that backlog number is working against us right now. So the topics today, evaluations, service life predictions, and life cycle costs. Let's try to zip through several slides here. I look at these and they're very related with each other. And you need to evaluate in order to understand the service life condition of your structure, and then eventually need to apply a life cycle cost to it. Let's talk a little bit about the evaluations first. You look at evaluations, you need to look at your operational objectives first. These operational objectives are what's the business side of this asset that we're dealing with? What's the service life expectations? What's your budgets? What can budgets be? What's your schedule? How does the repairs impact the operation of your facility? And different owners have different term of consideration, short-term versus long-term. You also need to understand the structural condition. In order to do that, you need to review past evaluations and assessments. You need to look at the structural details. You need to look at the condition of the steel material, and you need to look at the concrete material in these different structures. Well, we're going to look mostly on the reinforced concrete condition because of the conference that we're here. You do, in an assessment, you look at visuals, crack survey, you look at all the surface issues, concrete issues, and reinforcing issues. And I'm going to get into each one of those separately. As far as the surface issues, when you do an evaluation, you have to look at the membranes, the coatings, the sealers, any kind of scaling, pop-out, spalling, abrasion. All these are part of the surface evaluation that you're looking at. Now, concrete issues, these are what is the permeability or the transport properties? How contaminated is that structure? Do you have carbonations, chloride ingress, sulfates? What other degradations do you have occurring? Alkali-silica reaction, freeze-thaw, leaching. And then what are the current existing protection systems on that structure on the concrete, whether you have corrosion inhibitors present, different types of reinforcing, sealers, and other densifiers that have to be all considered in the existing protections. Then finally, in the assessment, you look at the reinforcing issues. What type of reinforcement, whether it's black, epoxy-coated, galvanized, sheath PT. You look at the corrosion activity on the reinforcement, the cover, the protective cover that's associated to the concrete over the reinforcing, if the use of that structure needs strengthening or not, and if there's any cathodic protection system present. All that should be included in an evaluation program. Once you do the evaluation, you end up with a situation. Now this is 2D diagrams where you have time versus damage. Damage on the vertical axis, and eventually you'll have enough damage that you have end of serviceability. On a new structure, you have good condition while the concrete's contaminated. Eventually you get to a corrosion initiation, and then you'll start having damage cycles occurring on the average part of the structure. At one point, where it's noted by number 1, you're going to end up having a repair cycle on that. That's going to bring back and drop down the damage on your structure, bring it down towards the original service, and then you'll start getting damages occurring again. And then you'll have another repair, and this cycle keeps going, and this is a very typical condition until eventually you can't repair it, and it's the end of the service life for this structure. Other aspects of this is that you can actually do a better repair and bring that service life closer to the original serviceability and have the repairs last longer. Now that's the point of our organization, is to make better repairs. And if you look at on service life predictions, you can look at what the effect of those to get the same essential service life of the structure. Or even better yet, let's go and do multiple ways of protecting the structure so that you end up with a much more deeper condition being brought back to the original serviceability, and a better repair that will take you out so you have only one or fewer repair cycles to the end of service life. Then you can also look in typical situations here where you have small amounts of damage and you start repairing it earlier, and then you can keep up with this, and now you're looking at extending the serviceability of that beyond the original service life of that structure. This is how we can get sustainability in concrete structures through concrete repair. Also, you can look at a combination effect of putting a preventative maintenance program on there, extending that time of critical contamination on the structure to extend that time of initiation of corrosion, and then delaying your corrosion activity to the time of repair, and then you can manage your structure in this fashion. I'm looking at different cases of generic cases. Then finally, the final case, 6 here, is that you can put preventative maintenance programs on several times, further extending the time in which corrosion will start, and then you can have minor repairs, and you can extend the service life of that structure by proactively looking at your structure through the life of the structure to maintain its serviceability and sustainability. Attaching a cost to each one of these events is depicted here in a relational basis. There's no actual numbers. It's 1.0 being the top, 0 being the bottom. We're looking at different repairs, and as you wait and wait and wait, and your structure gets older and has had repairs, your costs will go up. Likewise, you'll end up having higher cost in certain situations with better repairs. And even further yet, if you do a significant repair, proactively looking at it in a fashion of multiple mechanisms on how you're going to protect it, you're going to end up with a much higher cost. Likewise, you'll have costs associated with proactively repairing, but they are smaller in value. And we'll just move on here with time here, but if you look at the proactive approach, you can spend a little money here and there, and then a smaller repair to get a much longer service life on that structure. Well, that's the service life side of the presentation. Now finally into the life cycle costing, where you look at life cycle costing typically calculates a net present value on a option that you're looking at. Essentially what that's telling is what kind of dollars do I need to put today to take care of the facility for those different events and service lives in the future. It's typically related to opportunity costs. So if you're a private owner and your ROI is high, your interest rate that you're considering to bring back to net present value is higher than it would be in a public agency with bond rates as typical rules. All right. Then when you do these calculations, your net present value calculations are brought back. This cost is brought back to today's dollars, or this time period dollars have been brought back, and that's how that's done. You can also look in more complicated situations bringing those back. But it's also important to look at today. Often these comparisons aren't done at the time of initial construction. They're done at a time today when I have to have a repair. So you can do a calculation of net present value over the life of the structure, which would be the ideal way for sustainability from day one, or you can look at the net present value from today. If you look at just 3 of the cases in summary, if we looked at these and put a relational cost on these repairs and brought those back to either life cycle cost from day one or life's net present value cost at today's dollars, you get a relative factor with this being 1, this being 0, of the life of being 0.168 and today of 1.024. And then if you look at the case 3, you're going to end up having a factor here, and then you have a fixed cost here that is today's dollars, and there is no future dollars, but it is today's dollars in net present value. And likewise, you can do this for the preventative maintenance. And in summary here, if you look at doing net present value calculations on the life of a structure, you can see that the preventative maintenance program is much more cost effective on a relationship. If you look at it in today, we have an action to do today, that number is significantly lower than if you waited until there was problems and continually repaired under a shorter cycle with not so significant repairs. So today I spoke on the evaluations, service life predictions, and life cycle cost. Thank you.
Good afternoon. Again, my name is Andrew Vidor with Walker Restoration Consultants. My objective today is to talk about sustainability from the design aspect, and also to challenge everyone out here, whether you're a manufacturer, a consultant, or an engineer, or a contractor, is to find ways in which you can be more sustainable on your projects starting today. We don't want to portray the idea that we're not being sustainable with restoration already. We are. We've been doing it for a long time. What we want to do is be able to reinforce the point that we can always continue to improve on the processes that we already have, and that's why we're all here. So it's obvious that repairing an existing facility creates a lot less impact on the environment than investing all those new resources and depletion of energy to construct the new facility. So we want to repair rather than rebuild. There's a couple different approaches to sustainability, whether it's new construction or restoration. We need to first understand what the owner's expectations for sustainability are. More times than not in today's age, owners are requiring that if projects are not LEED certified or follow a Green Globe's processes, that they have to be designed sustainably. So once we understand those expectations, there are features we can incorporate into our projects that add little to no cost. and continue to make the project sustainable. Alternatively, there are certain aspects to our restoration projects that may cost more money, and as Paul said, it's important to make sure we look at that cost-benefit analysis to find out if it's really appropriate. That might be repair the concrete versus repairing the concrete and installing a coating system. There's a cost to that coating system. There's a life cycle cost for maintenance of that system. We need to understand if that's going to be the appropriate way to spend the dollars that are available. And certainly educating our owners, educating ourselves as consultants and as manufacturers and contractors, because certainly the more we know, the better off we're going to be in handling these situations. There's a couple things we can do with recycled materials. Certainly, we've been using supplemental cementitious materials for years. We should continue to do that with fly ash, silica fumes, or other pozzolans. We need to make sure we continue to use reinforcing steel and specify that the reinforcing steel and other metals in our designs include partially either post-consumer or pre-consumer recycled materials. What that means is we don't need to use all those natural resources from the beginning. Industrial byproducts. The industry is moving and becoming more accepting of using ground-up rubber tires as aggregates, glass, continuing to use slags. Local material sources is going to be important and continue to be important. We're already using the cement that's manufactured locally, but look at the other products that we include into our restoration products and make sure we try to use the local resources rather than shipping products from the other side of the world or the other side of the country when they're readily available locally. Another consideration for recycled materials would be reusing existing infrastructure for other projects. And this kind of falls into the LEED rating system for existing buildings. But if we think about if we're going to decommission a facility, we might have a precast spandrel panel. We may not need it on that project anymore, but if we can take it off, reuse it, and maybe use it as a wall, and then put in our infrastructure and our infill, whether it's a brick or some other type of facade system. So we don't need to use new CMU blocks or new poured-in-place walls. So specifications are certainly probably one of the most important things in a design project, because if it's not included in the contract documents, it's just not going to get done. So us as designers need to make sure that we are outlining very clearly what our expectations are for sustainability. Because right now there's an industry trend that everything's green, everything's sustainable. And I'm not going to connotate that it's not. But the fact is we really need to identify what is green, what is sustainable, how we're actually using those products, resources, or materials in our projects, and identifying if it truly is helping our environment and making an impact. So once we've taken that green wash away, we're back to the beginning and outlining what those expectations are. We need to start and continue to look at a systems approach to durability. The good thing we're doing now, we're repairing rather than tearing down. The next step is to repair, maintain, and protect. So that may be your concrete repair, that may be a sealer afterwards, that may be a coating, that may be a cathodic protection system to extend the life of the built environment that's already there and we've repaired. The idea of prescribing products with new technologies is something that we're always evolving upon. We are constantly changing our materials. We're refining our materials. We're improving our materials to make them that much better, to make them that much more sustainable and more durable and last longer. So we can take what may have been a 5-year repair 10 years ago and make it into a 10-year repair now, using the same methods, but new technologies of products. I think the industry is going to start looking at performance requirements more and more for our products. We're going to start requiring and looking at outlining the objectives. So the strength of our concretes, the durability, the life cycle analysis, whether it's Life Cycle 365 or other models, to make sure that our products are going to last, and put that on the product manufacturers with the work of the consultants. And the idea behind that is one person's project and product may be just as good as the next, but there's some nuances to those different products and making sure that we are evaluating those appropriately. And certainly high-performance materials. We want concrete that doesn't crack, that's not porous, and that's going to be durable for 20 years. So what does the owner get out of this? They're investing a lot of money. They may not be building new, which is good because it's costing them less money, but we're going to continue to provide them high durability products and projects that will require long-term less maintenance and less repair. The bottom line is that check that they're writing for the project. If they can write one check now that costs them a bit more money, the life cycle cost of that certainly should be less. And it reinforces the point again that what can we each individually do to be more sustainable? Educating the clients and the end users and their employees is certainly going to be an important part of that, so they recognize that by restoring, rehabilitating, and repairing, we are helping the environment and being sustainable. Right now, there's $2.6 billion available from the Department of Energy for energy-efficient improvements. I know it's not concrete specifically, but it's sustainable. The structures we work on have more components than just the concrete and the steel. So we can consider as a sustainable project as a whole to include looking at energy-efficient systems and energy improvements. One of the biggest things that everybody sees on a construction site is a giant roll-off dumpster, right? Where does that concrete go? Where does the boxes go? Where do those empty pails of caulk go? Everything goes in the dumpster. Here's a simple thing. Let's get 4 dumpsters. Separate the concrete, separate the steel, separate the cardboard and other recyclables. The opportunities therein lie, we're not taking one dumpster of debris and burying it forever. We can take that steel, recycle it, and hopefully the cost and economic hauling charges can be offset by the money we get back from the steel refineries. Take the concrete and drop it off at the concrete recyclers. They use it for road base aggregate. They use it for fill materials. If nothing else, we're not dumping it in the landfill. So again, I challenge you to find out what you can do in the industry today, tomorrow, and beyond to be more sustainable, to consider ways in your designs, in the way you construct your projects, in the way you manufacture your materials to be more sustainable in the long haul.
Hi, I'm Tanya Comas from California State University, Chico. I'm going to change it up just a little bit and talk to you about academic resources that you might use in your quest for sustainability. Very quickly, if you're not familiar with the Concrete Industry Management Program, I can talk to you separately about that later, but essentially it's a technical degree program with a required minor in business at 5 universities across the country, and they're listed up here, overseen by a national steering committee. And at Chico, we're in our 3rd year, and we're actually rated in the top 10 of sustainable universities in the country. There's a number of things that play into that. But so essentially, and there are other universities as well, not just the CIM programs. But this gives you a little bit quick overview of what, technical courses, business courses. At our university, we now have a sustainability minor that's an option for the students, and we offer a concrete sustainability course that's required. We do a lot with industry. Some of the courses that we do as a fundamental course, students do the ACI certification in their sophomore year, 2 ACI certifications. In their junior year, they'll be taking a concrete repair class, and we intend to require the ICRI certification as a part of that when it's ready to go. We have a lot of patron input, industry people coming in and working with the students in the lab, providing field trips, giving the students experience with their materials and processes. I put this up here for a reason. You'll see it in just a minute. And I also took the liberty, and you'll see as we move forward, to put some humorous stuff in. It is Friday afternoon, and I thought I'd lighten it up a little bit. But we're also doing a decorative class, and the reason I show that, oops, this is a sensitive arrow here. The reason I show some of the decorative work that we do is that at our university, and I think we're a good place to kind of start this out, we require repair followed by decorative concrete, with the idea that you learn how to repair or get surfaces ready to receive decorative applications, and in many cases that may save an installation or something. For instance, the walkway in front of Kendall Hall on our campus is in really bad shape. I have no idea why that did that. And part of the solution for this is going to be, rather than tearing out the entire walkway, this is the main administration building, we may have an opportunity to work with facilities management, repair all of that, and have a decorative finish when it's all finished. So it's bringing one more step to the repair process, and the decorative part of it is what has interested the president of the university in working with what we have rather than just completely tearing it out. Many campuses across the country are initiating sustainability objectives. We had 5 strategic priorities at our university. We now have a 6th, which is sustainability. I think something that we can provide industry is working with new ideas. One thing is, pervious. The CIM program at Tennessee, Middle Tennessee State University, is doing a lot of research with pervious concrete. In the sustainability side of things, it has a lot of benefit. But we should already be looking forward to maintaining and repairing pervious concrete. We don't even have a test method for strength of pervious right now. That's going through ASTM right now. And Dr. Heather Brown is working on that. But I think to take it even one step further is to look at maintenance and future repair. Decorative concrete applications with pervious. And so this is where I think we can work even more together with industry, which is, I don't see that our lab will become, and I know Tennessee's is not, and many of these other schools, that we're not planning on, if you look down on the bottom there where it says certified versus exploratory, we don't intend to be the types of labs that take the place of industry testing labs. What I think our purpose more is in proof of concept. You have an idea, a new product, a new way to do something, and you need a group of students and an existing lab to run through some ideas and come up with perhaps testing procedures. And what we can do in those labs is then outsource that to the other universities and provide round-robin testing and just a playing ground to figure out new ideas and approaches with some student input to help with some of the heavy lifting there. One of the reasons that our lab, even though our university is very sustainable, our lab, I have to admit, is not very sustainable. But when you have a flood, that instigates wastewater recycle in the lab. So our students are actually coming up with a wastewater recycle system for our lab, and they will learn how to treat the wastewater from the projects, reuse it in concrete, and it's a continuous process because we're really committed, I'm telling you, to not using excessive resources. And so sometimes we do these compression tests by hand. We don't have to run that big machine. The other thing, senior capstone projects, whether they're undergraduate or graduate, there's a lot of students out there looking for new research projects. So think of those students as resources. We have interns that love to get out and work with companies, and employment opportunities, obviously, and the more I can get students to come to ICRI, the more I'm hoping that they'll stay in this part of the industry. And then the last thing about sort of the universities, which is not just the tangible lab stuff and the workforce, is that we can act many times as a team builder to bring together different parts of the industry on new innovative projects that may not have funding already out there. For instance, there's Caltrans, we're talking about was it the D- that the road conditions have? California's looking at a huge condition assessment of state highways. And our university was able to help bring together several individuals from across the country and work on proposals for that. So team building at the university level with a lot of resources from different areas. All of these are coming up. Yeah. I really don't know why these are coming up like this, but the sky in France is really not purple. This is an example of one of those unfunded projects that the university has been able to get involved with. Auburn University, Texas A&M, and Chico State doing the evaluation of the bunkers at Normandy. But that's an example of a type of project that wouldn't have existed had it not been for the universities pushing it. So I'm going to move now from really educational resources into just a quick review of some of the practices of the historic preservation movement as a whole and where I think concrete repair can lead into that. Prior to 1966, when the National Historic Preservation Act was begun, there were several national acts beginning in 1906, the Antiquities Act, 1935, the Historic Sites Act, 1949, the National Trust was formed. After World War II and the Urban Renewal, then we have the National Historic Preservation Act of 1966. And the reason I'm bringing that up is, I'm not sure if all of you if everybody is clear on the fact that there is a federal tax credit for historic preservation that still exists, and it's one of the strongest revitalizing factors in smaller communities in the country. It's been going for quite a while now. It's essentially not unchanged, even in this day and age. 20% tax credit on a certified rehabilitation of a certified historic structure. And there are a lot of misconceptions about what that is. And I'm going to show you through a series of fun images what some of those reasons and misconceptions are, and I think reasons why people don't pursue this route for funding for reuse of a building. And some of the academic programs in historic preservation, I think, are another source for you guys to get more information on this. There's also a 10% historic preservation or rehabilitation tax credit available for non-historic buildings built prior to 1936. And it's amazing to me that in this day and age, all of those credits still exist. So again, I'm going to show you a few things about the philosophy, the misconceptions about historic preservation, and then the commonalities that historic preservation in a broader sense have with concrete repair. The thing I want you to notice as I go through these is right down in the corner, there are dates on these cartoons. This is 1970. All right, how long have we been talking? When did sustainability happen? Fairly recently. This series of cartoons that I'm going to show you to illustrate a few of the points, some are from the 1960s, and this is all right up and leading up to the National Historic Preservation Act, and my point here is that what we're doing in concrete repair, we've been doing this for a really long time before anybody called it sustainability. Anyway, this shows what it says there. We've programmed it for solutions to the energy crisis, and what comes out is preserve. I have a great example of where this sustainability thing can sometimes go too far. In New York City, there was a building being restored, and they were going to replace all the historic windows, put in all the new air conditioning, and a creative engineer thinking outside the box decided, wait, if we don't change out those historic windows, he calculated the load of fresh air leaking in through the historic wood windows. They didn't put in any fresh air system. They left the historic windows and counted on the leaking air from the historic windows, which I thought was very creative. So my point is the sustainability thing can sometimes go a little too far. Not all solutions fit. Even if a LEED credit is available or some other credit, should we tear down a good existing building? Well, not always. Building more with the idea of permanence. And I think we've already brought up the idea of new construction that we can reuse, not just tear down. Humble beginnings of the historic preservation movement with the Mount Vernon Ladies Association. Existing sprawl, there's a fallacy that people think that you can't put a new building next to a historic building in a historic district. Actually, the Secretary of the Interior standards that provides for the tax credit would prefer a difference between old and new. Simple fact. New addition to a historic building, let it look new. It does not have to match historic. Whoop, that's a very sensitive arrow there. A lot of terms in historic preservation, just like we're trying to figure out green versus sustainability, what do those two things mean? In the world of historic preservation, there are specific terms, and this is kind of the mantra of historic preservation. Reuse before rehabilitate, rehabilitate before restore, and restore before reconstruct. And I think this is an important point, which is we're not only preserving historic buildings, but we're preserving our past. We're preserving how will we know it's us without our past? That's a real kind of common quote used in the historic preservation part of things. But it's not just about physical buildings, it's about cultural. And, oh, here you go. There we go.
All right, now we'll come into the non-technical portion of the presentation. I am not an expert in concrete or concrete repair, but when it comes to sustainability, the U.S. Green Building Council and the LEED rating systems are probably terms that you've heard tossed about. If you haven't, you probably will in the future. The U.S. Green Building Council is nation's foremost coalition of leaders from across the building industry. The U.S. Green Building Council is a consensus-driven, industry-led organization that's comprised of members from across all sectors of buildings. So it includes building owners and operators, includes developers, it includes designers, architects, contractors, engineers, trade contractors, product manufacturers, pretty much anyone who touches a building, USGBC is applicable to. Our mission to transform the way buildings and communities are designed, built, and operated, enabling an environmentally and socially responsible, healthy, and prosperous environment that improves the quality of life. So the reason this is important is you can see from this graphic that buildings have a tremendous impact on the environment. And that green buildings or sustainable buildings obviously can save tremendous amounts in energy, in carbon, water usage, and in waste that can be diverted from the landfills. So just a little bit quickly about the council. You can see here that the membership of companies has been growing steadily, and it will continue to do so. This slide was updated in January, and as of now, there's over 20,000 member companies within the council. A lot of the things driving this is there are not only state, but federal and local governments are mandating green building policies. So the council provides not only the LEED rating systems, which you've heard about, but the council provides education through webinars and LEED workshops, a credential, the LEED accredited professional. I don't know if there's any LEED APs out in the audience, but that's also something that the council has developed, as well as providing research for the future of sustainability. USGBC has a $2 million research budget this year. And providing forums. A lot of the council's work is done through the local chapters. Most of it, there's, all of you are encouraged to go back, and if you're not already involved in your local chapters, to check out. There's a little map. There's over 78 local U.S. Green Building chapters or affiliates currently. And I mentioned the LEED credentialing program. There's currently over 81,000 LEED APs as of January, which there's going to be a change to the credentialing program, and from what I've heard, this number could jump up close to 90,000 in the next month or so. So here's a quick peek at the new credentialing process. Any of you who are current LEED APs probably know about this, but the process is going to provide even more credibility because USGBC is offering different levels of LEED professionals now, and also specialties. So it's not just one overall. They've realized there's different levels of knowledge as well as different areas of expertise. And also with more of a stringent maintenance program will make this a much more credible credential. The LEED rating systems. LEED stands for Leadership in Energy and Environmental Design, and LEED is nationally and internationally known as the leading edge certification for green buildings. There are other rating systems. I know Green Globes was mentioned. The thing that's a little bit unique about LEED is it is a third-party certification, and it is quite rigorous. So the philosophy behind the rating systems is just as you would want to know what's in the foods and the nutritional values of foods that you eat, that you should also know how sustainable and what are the sustainability facts of the buildings that you occupy, which we do spend about 90% of our time in buildings. The LEED rating systems look at 5 key areas: the site planning, water management, energy, material use, and indoor environmental quality. And LEED allows buildings to earn points within these 5 categories to achieve various levels of certification. There's 4 levels currently: certified, silver, gold, and the highest is platinum. The nice thing about LEED is it applies across all building types as well as the part of the building's life cycle that it's in. So whether it's new construction, might be a tenant improvement, or the operations of an existing building, there's a rating system for that, as well as various market sectors such as retail and schools, et cetera. So just a quick few statistics here. There's currently over 17,000 projects registered across the country, and there's currently close to 2,300 projects that are certified across the country. And here's just a quick peek at the statistics of how that fall off over the nation. You can see that it applies pretty much everywhere, and from these statistics you can see that it's continuing to grow, and it's something that is important for you to understand how your industry and what you do in your professions, how it applies to LEED, and be able to speak to that factor so that you can talk to building owners or designers or people that you're working with. So I would encourage everybody, this is just a quick example. I obviously don't have time to go through all the LEED credits and rating systems, but if you go on USGBC's website, usgbc.org, you can download PDF versions, short versions of all of the rating systems for free. This will show you the credits that are available within each rating system, as well as how many points can be earned, and it will show you the intent. So here's an example. This is one that's probably right now pretty relevant to concrete repair. This is out of the new construction materials and resources credit building reuse. So it's going to show you the intent to extend the life cycle of existing building stock. It's going to show you how many points can be achieved. So you can see just in that credit alone, depending on how much of the building can be repaired and reused, you can earn up to 3 points under that rating. Talking about the pervious concrete as a future, that's going to be particularly important. There's a wave of, within LEED, of the existing buildings and really preserving the buildings and operating them more efficiently, and a lot of pervious pavement is a part of that. So I think it's important for all of you to understand, to take a look at the rating systems and see what your services and products are, and read through and determine how they can help to earn points and be able to speak that way to people that you're working with. Some other ways that you can get involved, joining USGBC. If you want to have a voice for the future of LEED and how is concrete and concrete repair going to fit in with that, USGBC is a consensus-driven organization as well as LEED. Member firms, the new LEED versions are balloted through member firms, and you have an opportunity to have input into that. And also I would say get involved with your local chapters. That's where really the work happens of USGBC. The chapters are meeting with city planners, they're meeting with city councils. They're out and about, and they have a voice not only in the local community of sustainability, but they do have a voice with USGBC National too. So hopefully everyone will take away from this, check out the website, look at the rating systems, and see how it applies to you. Thank you.
Great, thank you very much. I'm the last speaker, so we're getting close to the end, and I have two principal objectives. One is to kind of summarize what a number of the previous speakers talked about, and number two, to try and quantify how this can be used and related back to concrete repair. And just before I do that, I want to just read something. This issue is becoming more and more prevalent in our daily lives. And when I was reading the newspaper at home last weekend, this is after the slides were prepared, there was an article in the newspaper, which is essentially about sustainability and environmental responsibility. And there's a statement in here in the second last paragraph that says that the greenest building is often the one that is already built. And this is just an article in a general sense talking about sustainability, and you know, it's reflecting many of the same issues that we're talking about here today. So Fred in the beginning talked a little bit about the impact of concrete on the environment, and as he said, we make about 6 billion tons of concrete per year. It's a huge consumer of raw materials and energy. It contributes a lot of CO2 to the environment, about 1.6 billion tons per year, and also results in a lot of other environmental pollutants, carbon monoxide, nitrogen oxide, sulfur dioxide, and a few million tons of VOCs. It also dumps a lot of waste heat into the environment, and that thermal pollution isn't often talked about, but it is responsible for raising the temperature in the surrounding area. And if you do a quick calculation, the amount of heat that's given off by the amount of concrete that's produced each year is roughly equivalent to the amount that's required to raise 1 million square kilometers, that's about 500,000 square miles, of ocean surface by approximately 1 degree Celsius or almost 2 degrees Fahrenheit each year. It's a large amount of heat that's being dumped out there. And all of these things obviously impact on the environment. Despite all of these factors, concrete is and can be quite environmentally responsible. It can be one of the most environmentally responsible materials if it's used appropriately. And when I say used appropriately, I'm really talking about using it in ways that it lasts a long time. If we can use it in ways that it lasts a long time, then the environmental impact is quite negligible, much less actually than wood and other materials if you get the life out of it. And so I just want to throw in a couple of, pretty much from here on in you've got pictures, so this will be interesting to see. This is a picture of the oldest concrete structure that I'm aware of that's still standing in the world. It's in Rome, and many of you know it's almost 2,000 or around 2,000 years old. It's not Portland cement concrete, it's pozzolanic cement with aggregate, unreinforced as a dome. The oldest bridge that I could find a picture of, and there may be others, but this is a picture of a bridge in Portugal. It was built in just 1224, I believe. It's roughly almost 800 years old now, and it's still in service. Probably doesn't meet current codes, but it's been there for a long time, and it's got car traffic on it now and wasn't probably designed for that 800 years ago. Here's a picture of a bridge here in the States. This bridge is this one here is built in 1987, so it's roughly 30 years old, and it's not in terribly good condition, despite the fact that it's a lot newer than some of these other things we just saw. You may find it interesting to note, you can go and take a look at Federal Highway's website and read through some of the statistics there. If you look at the bridges that were replaced in 2006, which is the most recent year that's posted, the average age of the bridge deck that was replaced in the US was 20 years old, okay? That's being replaced. That's not being repaired. That's the average age of a bridge deck that's being replaced. And obviously some of those are being replaced because of functional issues, but many of them are being replaced because they weren't designed with durability in mind. So Paul was talking about the need for durability, and we can do a lot better job in designing new structures. As far as I'm aware, this is the first bridge in North America that was explicitly designed with a 100-year service life. This bridge is actually up in Canada and connects Prince Edward Island to the mainland, and it was built in the late 1990s. It's approximately 10 years old now, and it was designed with a 100-year design, build, maintain, service life type of approach. The longest design service life that I'm aware of in North America is a cathedral. It was just built not that long ago, within the last 10 years, in Los Angeles. It has a stated design service life of 500 years. I had a call from the architect when they were doing the design of this back in, I think it was 1997, and the Archdiocese in Los Angeles district was looking for a 1,000-year service life for this new cathedral, and in the end they negotiated with the Archdiocese and they settled on a 500-year service life on the basis that the architect convinced them that they couldn't model anything beyond 500 years. It's probably academic, because whether it's 500 years or 1,000, it's certainly a lot better than 10 or 20 or 50 years. And we can definitely do this with new structures. But we're in the repair industry, and most of our jobs really are dealing with existing structures, obviously. And what are we going to achieve with repair? I picked two examples. And the only reason I picked these two examples is because they're projects that I've been involved in, our company's been involved in, so I have the data sufficient to do the calculations that I wanted to do. And the first one here is a repair of a historic bridge in Idaho, where they wanted a 50-year service life extension for an existing bridge that was 75 years old. And what can this relate to? And we can calculate directly the benefit of doing this type of rehabilitation. We know that they wanted, and it was designed to get a 50-year service life extension. We know that there were slightly over 1,800 cubic yards of concrete in this bridge, and that's primarily in the substructure and the arch of the bridge. And by maintaining that amount of concrete in service and not replacing it with an equivalent amount of concrete, if you assume that a new bridge would require the same amount of concrete as the one that you're just replacing, you can calculate directly the amount of carbon dioxide emissions that are not released. And that calculates in this particular example out to about approximately 450 tons. It's not billions or millions of tons, but it's still a lot of CO2. You can also calculate the embedded heat in that amount of concrete, and I'm a mechanical engineer, so that relates to about 4,800 gigajoules of heat. A joule is really quite a small amount of heat, but a gigajoule is a hell of a lot of heat, and 4,800 of them is enough to boil 3 Olympic-sized swimming pools, and that's not an insignificant amount of heat. And if you take a look at it on a personal level, this amount of CO2 impact is approximately equivalent to the annual emissions of 90 average people in the world. The second example, just to show you that you can do this twice, is repair of a dam, a hydroelectric dam up in Manitoba, Canada. Here the owner was looking for a 40 to 50-year service life extension. There's approximately 38,000 cubic yards of concrete in the structure, and they were maintained in service by not replacing the structure. The CO2 equivalent of that amount of concrete is approximately 9,500 tons. It's equivalent to the annual emissions of approximately 1,900 people. And it's kind of ironic because that's relatively close to the number of members of ICRI that there are. Now, ICRI number of members is now greater than that, but this one project, maintaining this one structure in service, is essentially in a way offsetting or reducing CO2 emissions that would otherwise have been produced. And if we think of this as one project, it's a very significant project that our firm was involved in, but all of the people in this room are involved in many, many more projects than we are, and the total impact of all of these projects is much greater than what I can really show in a few slides. So just to close up here, I'd just like to issue a kind of a call to action, and I really have 3 points to the call to action. The first is that we need to think about the reality of the situation that we are in. Secondly, we need to accept responsibility for the situation, whether we feel that we created it or not. We need to accept our responsibility for the situation where we find ourselves. And third, we need to take some action. And that's really what the principle or the basis behind this forum is. So I'd like you to think about those 3 points, and I'm going to turn the floor over to Fred. Thank you very much.
Okay, I'd like to now open it up to questions. I thank you all for your patience, and I'd very much like to thank our excellent panel of speakers. If you would like to address a question to a specific speaker, please speak loudly. We do not have floor microphones, so we'll try to repeat the question. I saw a hand raised in back. Doc?
Where does ICRI go with the sustainability process? Obviously, it's the way of the future for all industry in America. What does ICRI do with it? Where do we go with it?
The question is, where does ICRI go in the future with sustainability? And I think that's the purpose of this forum, to acknowledge the fact we need to be doing some things with sustainability. It's an area that impacts our life on a daily basis in the concrete repair industry, and it's under-marketed, underutilized, in my opinion. Any of the other panelists want to supplement that?
Hey, Fred?
Yes, Peter.
like to thank you for your volunteer.
Oh. Gee, one more thing to do. So who's the victims here? Myself?
Pat, raise your hand, Pat.
Okay, Pat Winkler and Peter Golter, and myself apparently have an assignment to do something about all this. So since you brought it to my attention, Peter, you're in charge. Tell me what you need.
Fair enough.
Okay. Next question, Garth.
Well, just, I guess, a comment to that question, and furthermore to what people in the panel were saying, is that, we've talked about concrete repair in concept, we've talked about the concept of concrete repair, and you agree using structures in concept here as being sustainable, but I think part of it is getting the facts and getting the data put together to be able to take that out. And I really see it as where ICRI is in a position with so many people from the industry to collect those facts and we'll start putting them together and creating the story. So,
I guess we're going to really push Garth on. The real question was, are we going to do something besides talk about it?
Are we going to do something more than talk about it?
Yes, no, it's actually
The three of you
part
are, apparently.
from the TAC committee to have something in place within 5 years, getting it out to the marketplace, educating the marketplace. Again, it was just discussed not even 2 hours ago.
Okay. So the end game is a guideline, the end game is a rating system.
It could be material, it could be process, structural, life cycle, specs, guidelines, product selection criteria, leads associated with that. You could also then look at historical preservation, the comments that Tanya made up there. From the material manufacturers, life cycle 365 testing, design as far as making sure we got 1.5 inch cover over rebar, the type of rebar that we're using. Are we going to stainless steel? Are we going to impregnated, oil impregnated steel? What are the things that are out there that can help us give us extended service life and reduce life cycle costs?
Okay. Very good.
Excuse me, I'd like to answer, Garth had a great point, and I'm not sure if 5 years is a good window. I think if we came together with a white paper from an industry, we can come up with a white paper that everyone, there's 1,900 people, can be marching that around with their local governments, their local communities, and that could be done now. I mean, if the white paper was put together so it's not overbearing, but it says repair, maintain, this fix these structures so that we bring that sustainability, we can do that. We can have impact and build momentum far quicker than 5 years. I think we can do that with that committee if they came up with a white paper, just a description of the impact that we can have.
And the approach is crawl, walk, run. Yes.
Right. Spread it around. Have every member of the ICRI passing that around. I think that would be a great start, and see where it goes from there.
Next question. Chuck.
I missed the first part of the speakers, and I apologize for that, but could someone explain the relationship between the U.S. Green Building Council and BEC, for example, if there is any?
What is BEC?
BEC is just an acronym for Building Enclosure Council.
Okay.
I don't think there is a relationship.
Okay.
Insofar as, BEC flies under the banner of AIA, but I don't know if there's any formal relationship between those two.
Do they cooperate with each other, or do they recognize each other, or is there any comedy between them, if you know?
That I don't know, but can I ask you a question that might piggyback on yours a little bit?
Go right ahead.
With relation to LEED, I mean, the question would be is what is USGBC doing to recognize and put more emphasis on the benefit of reusing an existing building structure? 3 points for reusing a building does not seem to be proportionate with the benefit that's delivered in so many different ways. They've enumerated some of the benefits. They go far beyond that. To put a bike rack in, you get a point. So reusing an entire building shell or putting in a bike rack, they don't seem commensurate. And I'm just wondering what USGBC's position is, or if that's going to change, because at this point, that doesn't seem like a friendly policy to building restoration.
I can't answer the question that they're doing anything specific towards that. The way that they've determined in LEED 2009, they have done a sort of a scientific weighting of credits in order to determine what's going to have the greatest impact. And they've determined right now that energy is the #1 issue right now and the #1 thing that they're going to focus on. So the credits in the LEED rating systems are more heavily weighted towards energy. But like I said, LEED is a constantly changing rating system. That's one of the things that's great about LEED, is that it continues to improve and it continues to change, and that's where you can have a voice in it, and that's where I encourage the changes that come through LEED come through people like you voicing their opinions, and all of the innovation credits are tracked. All of the credit interpretation rulings are tracked, and all of that is taken into account when new rating systems are launched. So that's where I think it is beneficial. And you asked the question with a specific organization, but check out your local chapters of USGBC. I know all the local chapters are working with organizations that have similar goals, and to try to collaborate to have an impact on future versions of LEED.
Is this a different question, or?
Well, it's just along the same line.
Okay.
I think one of the challenges, though, is that the USGBC membership in general is not all that interested in existing buildings. I mean, I think that's the rub. It's that they're more interested in new construction.
Right.
Well, I would say that has been the trend, but I can definitely say that trend is changing, and that at first, LEED is relatively new. It's only 7 years old, and that the glamour of new construction definitely was shining in the beginning, but I can tell you that there is a huge shift towards understanding the importance of existing building, and that's one of USGBC's strategic initiatives for this year, is to focus on existing buildings.
I also think that that's one of the main reasons why we need to be involved, right? We need to be involved early on, and we need to influence these decisions that are being made, because there's nothing wrong with the people who are making them, but just the people that happen to be part of this group are, like you say, they're principally architects and structural engineering firms and whatever that are involved. The vast majority of their business is related to new construction. And so obviously that's going to be something that they think about, and they're not going to think about repair in the same way that we think about repair, because it's not their core business. So I think it's part of our responsibility, really, to make sure that the facts and everything are actually being put there in front of them, so that they can be maybe more fairly considered, right?
One of those examples of how the U.S. Green Building Council has evolved from its infancy started with new construction. There's now one for homes. Their industry has recognized that when this first started, homes are very different than a commercial structure, much as our schools. It's a nuance to that. And so the industry groups have banded together and made that distinction that, as an example, we need a specific category for LEED for schools and LEED for homes. And so our opportunity here as the industry of repair is, the opportunity would be to create and help and work with USGBC to develop LEED for restoration or LEED for repair. And it would be our goal and our mission as the industry organization that knows it best to be able to approach USGBC with those opportunities. USGBC is just acting as a moderator on behalf of all the different industry organizations, and so they need our expertise and our knowledge and brain trust to be able to develop and create those standards.
I was going to add to that I think we need to broaden the discussion beyond just LEED or the Green Building Council, because, I mentioned that there's a 10% federal tax credit already in place for non-historic buildings built before 1936. They don't have to be historic. It's a 10% tax credit. And that's through, the preservation movement, but it's really one and the same thing, in that, maybe LEED is doing such a great job with new construction that LEED wasn't isn't the answer to existing buildings, but you can piggyback these things and get them to work together instead of reinventing the wheel on some of these, and getting involved perhaps with like the Association for Preservation Technology and some other groups who are tackling this same issue about historic buildings, and that, you know, decide whether it is the purview of LEED or not, or do they play together without having to completely be a LEED certification?
A couple of points that are fairly unique to concrete structures. Concrete is an extremely energy-intensive material to produce, yet once it is in place, it's extremely energy, it doesn't use a lot of energy. It stores it very well. It has a high amount of thermal mass. It doesn't require a high amount of maintenance or other consumable materials. Secondly, concrete, unlike many other construction materials, is extremely benefited by proactive maintenance. And I think by emphasizing maintenance and prevention with concrete, we can do a lot more to enhance the durability of the structures. A little bit spent up front before corrosion is initiated can have a huge impact many years down the road compared to waiting for the rust to show up in the cracks and then say, what the heck do I do? Christopher.
Another question. For your players statistics, 300 million square feet under the roof in the U.S. of space, and a lot of that space has been constructed since 1965, 70, so it's recent buildings that don't fall into the category of historic. Many of them aren't lovable unless you really like the 60s and 70s and the Brady Bunch. But yet, there's a tremendous amount of embodied energy, emotion, investment in those buildings. We can't afford to throw them away. We can't throw away that energy. We can't landfill them. There's no place to put them. The materials that we put back, and we're talking about saving energy, you ever see how much energy it takes to make aluminum or glass or steel, which are materials we would rebuild with today. My question for Dr. Comas is are you aware of, or is anybody aware of, has the National Historic Trust moved beyond just talking about 50 years and older historic into trying to deal with the problem we have with the recent past?
One way that's dealt with already is a National Register Historic District can contain non-contributing buildings that qualify because they're in a district. And what he's referring to is that generally the National Register recognizes buildings 50 years older or older. And if you think that we're in 2009 now, those 50s and 60s buildings are historic. That's part of it. You can go under the 50-year mark even outside of a registered district for special circumstances.
Is anybody lobbying, though, like a 10% tax credit for buildings built before 1936, right?
Right.
How many of them?
Right.
Is anybody working on lobbying for financial tools to incentivize going back and reclaiming your middle school, or the factory that you had working?
The other part of that tax credit is the 20% tax credit for historic buildings. So there are two different tax credits. But the association that I mentioned, APT, the Association for Preservation Technology, is very similar to what we're doing here, but it's mostly architects, engineers, and university professors, so it's a smaller group. But they're very active in that, and they have a sustainability committee as well, and I think that would be a good link for us because they're already working with some of these issues. For preservation in general, new or old buildings, really it should be called existing buildings, not just historic. And that's really what they're after, is not just historic. But that's a group that's already doing a very similar thing to what we're doing, and I think, and they're not just dealing with concrete, but we could certainly have a big influence on that.
One more comment is that the concrete industry is fairly fractured. There's fragmented all over in different types of interest. But there is a group, the Strategic Development Council of ACI, that is trying to pull all those fractured groups together. And I believe that that's a good place to start. They're spending a tremendous amount of energy on this sustainability effort. We do need to get it to the regulatory people. We do need to get it to LEED and other people to make the change. And instead of the 3 points, let's make it 30, 40, where it really belongs. And I think that's what we have to do in lobby. And I guess the word lobby is a question. I don't know. I'm not as connected in this industry at the political side, but Do we have any lobbying effort from the concrete industry for this cause actively in place now? I mean, I'm just...
I don't know of a lobbying effort. I wanted to expand a little bit. An observation I've made from SDC's sustainability initiative appears to be that if you are representing the interest of producing Portland cement, you tend to focus on let's cut out CO2 emissions in the manufacture of Portland cement. If you are representing the interest of concrete production, you say, oh, let's keep Portland cement the same and use a lot of supplemental cementitious materials. If you are representing steel reinforcement, it's let's use more recycled steel in the reinforcement to save energy. We're such a fragmented industry, but this is the only organization that I am aware of that specifically addresses existing structures made of concrete, how to promote their longevity, save their history, and make them more usable through adaptive reuse, restoration, rehabilitation. And I think we need to get our voice out there. How to do it, I ain't entirely for sure. Next question.
Can I make one comment? Sorry to cut. Just, we've had a lot of discussion here specifically focused on buildings, and buildings are certainly a significant component, and obviously that's the main focus for LEED is buildings. But a large percentage of the concrete that's out there is not directly in buildings, you know, especially the really big things. You know, we've got a lot of civil structures, and these, you know, aren't buildings, so therefore they're not going to fall under these direct at least not as they're certainly written right now. They're not going to fall even under the historic things. Well, I guess in some cases they may, but we need to think broader than just simply for building applications, because the benefit is there in all of these other things as well.
Yeah. How much energy does a pier consume as it sits there, or a parking garage?
Yeah, or a bridge.
Or a bridge.
Dam, or
you know, it doesn't really fit into the calculation models. The other factor with many of these infrastructure type of structures is they are designed with a very long lifetime, which capitalizes on the benefits of concrete. Another concerning issue is when we have a natural disaster, what do we replace the structures with? I think back to the hurricane damage in the southern United States, and how did the construction techniques change as a result of that? I think there was a whole lot of stick construction that went right back in, and that's a little bit frightening. So,
there was a question.
Lori.
This is actually for Simon and the others that might be specification writers. How much do you struggle with the balance of using products and materials that maybe have a longer lifespan but may have more initial upfront cost or higher VOC content? You know, the energy that's, I mean, I'm sure you must have ways to calculate the energy that's embodied in that material or that product, and balance that with the expected life that you're going to gain with your structure. Is that something that you address with every design that you specify?
So the question is, as we're specifying products and repair procedures and materials, what we're doing as designers and consultants to really weigh out what the value is and the benefit of those additional capital costs. And it's an interesting concept, and there's a million ways to skin a cat. You know, some life cycle cost using Life Cycle 365, but it all starts with the owner's expectations. If, in our perfect world, in the repair industry, if we could do it right and do it once, we'd be done, and we could move on and fix the next structure. We don't have the checkbook to take care of these projects, so if the owner wants to spend as little as possible, there's not a whole lot we can do. We have to go with the chip it out, go into the bar, blast it clean, and put back in $40 a bag repair mortar. and move on. If the owner wants to be able to extend the life of their existing structure, this is where we get into the very dynamic models that Paul talked about, and looking at that life cycle cost and finding out if it's really worth it. There's not a true industry standard that says this is how you have to do it. It starts going back to professional judgment and what resources are available to determine those products.
I'm going to add to that, join the Life Cycle Committee. I think that's what we're trying to do. We're trying to provide a guide to owners and then a guide to engineers as to how to make those decisions with their eyes wide open. That they're not just making a decision, just, I don't have enough money. You make that decision and you kind of almost write off, here's what you're expecting from that decision. And I think the Life Cycle Committee is stormy and forming. We're looking at web conferences on developing the deliverables and who those audiences are. And I think we found on committee today that the owner and engineers are the ones that we need to have tools from this industry to help them make better decisions and to guide their clients to make better decisions too.
Next question. Unless you feel like all of these issues have already been addressed.
Great job.
So where do we go from here? What's our next steps? I understand there's been a tax subcommittee formed or discussed being formed. I don't think it's just the sole responsibility of 3 individuals who were named to the committee to take up this charge. What are you as a member of ICRI going to do? How are you going to contribute? What do you want to see our organization do? It's your organization. Kevin.
Fred, I think just confirmation on the TAC item. What we're trying to do at TAC is just begin to get some discussion and try to figure out what are some initiatives potentially that ICRI could do in this area. So it's really an initial brainstorming and see maybe then where those could go out within the organization and specifically technical committees, since that's tax responsibility. So it's not just these 3 individuals, which, by the way, I did not put your name in that hat.
It's nice when people own up to their accountability.
So that's the first. So the goal is certainly not to have this on 3 people's individual shoulders, but we've got to start somewhere with some sort of initiatives we can then move out to the rest of the organization.
Garth.
Is there a place at this point to set up a meeting for Phoenix, an exploratory time frame to have a brainstorming session on where the organization goes, what sort of structure you should have for following up on sustainability? Sort of following the lead of some of the other technical committees on masonry. First thing was to set up a time frame where everybody would get together one of the meetings and talk about, okay, where are we going to go and how are we going to go?
I think that's a potential excellent idea. That's really what we're trying to, that's what we're trying to do within this subcommittee attack within the next 30 days to mid-July was to come back to the executive committee and say, here are a few initiatives.
So your time frame is that short?
Yes.
Okay, that's good.
Anyone else have any discussion, questions, comments? Or is it Miller time?